Okay, so chapter 7 on memory. This chapter, we are going to discuss the three different types of memory: short-term memory, working memory, and long-term memory. Within each of those types, we'll also talk about how memory is processed. Then we're going to talk about also some really cool stuff that students always love talking about, and that is information like eyewitness testimony, autobiographical memories, repressed memories, and other topics like that. I think you'll really enjoy this chapter and learn a lot more about what memories are in depth, and also, learning about how you actually are able to process memories. So we're going to start off with Module 20, and this is on the foundations of memory. And there are three questions that we are going to answer in this module. The first one, of course, is what is memory? It may seem very simple to think about what a memory is, but there is, a more, descriptive definition into what a memory entails. We will then talk about, are there different kinds of memory? And the answer to that is yes, there are different kinds of memory. And we'll talk about what those different kinds of memory are. And then the third question we're going to answer in this module is, what are the biological bases of memory? We don't always think about, when we think about memories, we may think of them in a personal context or in a social context. We don't always think about them in a biological context and where in the brain memories occur. So the last part of this module will talk about that biological basis and the neuroscience of memories. So let's start out, discussing the foundations of memory. And that first question we asked is, what is a memory? So definition-wise, a memory is the process by which we are able to encode information, then store the information, and then later on retrieve the information. These three are extremely important in getting memories into your mind so that later on you can retrieve them. And so if you are studying for an exam, part of that studying process is encoding and storing that information so that later, whenever you take the test, you can retrieve the information. So let's think about what these three terms mean: encoding, storage, and retrieval. So first off, encoding is where you record information in a particular form that is then usable to memory. And we'll talk about the various ways that you can encode information as a way to get those memories into your mind. Storage is the maintenance of material that is saved in memory, right? You have to be able to store those memories so that then the third part, you can then go back and retrieve those memories. So this is where you're locating that material that you stored and you're bringing it into the present. You're bringing it into the awareness of the present moment so that it can be used, whether that be for taking an exam or whether that be for having a conversation with someone, whether that be for, having an interview, talking to the police, whatever it is, right? So these three, encoding, storage, and retrieval, are extremely important when it comes to memories. This is a picture kind of showing you how memories are somewhat like a computer. And this is figure 1 at the bottom of page 203 in your textbook. And it says memory is built on three basic processes: the encoding, the storage, and the retrieval. And this is very similar to what a computer does. So the encoding, this is the initial encoding of the information, right? So you're typing in the information. That then goes, once you save it, that is stored in your computer. And then later on, whenever you want to bring that back up, there's the retrieval or the recovery of stored information. So this is very similar. This is exactly what you do when you write a paper for a course or you're taking notes during class, right? You're going to type up your notes, you're then going to save them, and then whenever it comes time to study for the test, you're going to pull up those notes again. This is very similar to what your mind does when you are coming up with new information. This is another great figure. This is figure 2, and this is at the top of page 204 in your textbook. And this is going to show you what we call the 3-stage model of memory. We'll come back and we'll talk about this a little bit more, but this is just kind of showing you where you have this information, right? And that information goes to sensory memory. You're either going to see something or you're going to hear something, or maybe you're going to touch something, taste something, smell something, right? If you don't notice it, that information is gone within about 1 second. If you do notice it, if you do hear it, if you do see it, if you do taste it, that information then goes on to short-term memory. And if you don't send it on to long-term memory, then the information is forgotten within about 15 to 25 seconds. If you want to get information into long-term memory, we'll talk about ways to do that. Maybe through repetitive rehearsal. You repeat the information over and over and over again. It then gets into long-term memory. And from long-term memory, then, it is there to stay. So you have this 3-stage model, right? Sensory memory, short-term memory, and long-term memory. And these go from one to the other. So let's talk about this first stage in this 3-stage model. That first one is sensory memory. Sensory memory is that first initial momentary storage of information, and it lasts for only an instant. We say it lasts for about a second. Your mind is bombarded with all kinds of stimuli out there in the environment that you aren't even aware of. When you are aware of it, that's the sensory memory. If you don't pay attention to it, though, it's completely gone. But sensory memory is that first storehouse for the information. Sensory memory acts like a camera, like a camera snapshot that you have in front of you. So it stores information for a very brief moment of time. Now, there are 2 different types. You may have noticed that on the previous slide with that flow chart. There are 2 different types of sensory memory. There is iconic memory and there is echoic memory. Iconic memory is visual information. It stores visual information. Echoic memory, right? The word echoic, you think about echoes. Echoes are something that you hear. So echoic memory stores auditory information coming in from the ears. So iconic memory stores visual information coming in from your eyes. Echoic memory stores auditory information coming in from your ears. If sensory memory does not pass on from sensory memory into short-term memory, then it's completely lost. There is no getting it back. Okay? Then we said sensory memory lasts for about 1 second. If you pay attention to it, that information could go on to short-term memory. Short-term memory, as you can see in this slide, it's a memory, the second stage of this 3-stage memory. It's a memory that holds information for about 15 to 25 seconds. That's it. So now we are about up to 16 to 26 seconds of information, including that sensory memory of about a second, and now with a short-term memory with about 15 to 25 seconds. Short-term memory has a very limited amount of space. You can hold about 7 items plus or minus 2 in short-term memory. And so when we have a larger amount of information, what we do is we chunk that information. Chunking is where you take a group of separate pieces of information and you store it as a single unit in short-term memory. So if you look at this example, right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It would be extremely hard to remember 21 different bits of information. That's much larger. Remember, we said that you can only hold about 7 plus or minus 2. So that's 5 to 9 bits of information. And so in order to remember these 21 separate bits, we're going to chunk them into smaller units. So we can think of PBS, Fox, CNN, ABC, CBS, MTV, and NBC, the various channels that you could watch on a TV. If you think about a credit card, you have 16 numbers in a credit card. It's hard to remember 16 numbers. So if you look at your credit card, it is broken down into 4 different sets. And you could think of those sets as years or so on and so forth. It's much easier to remember 4 than it is to remember 16. So again, short-term memory, that second stage of the 3-stage model, holds information for about 15 to 25 seconds, and it only holds about 7 bits of information plus or minus 2. And so we may use chunking to remember that information better. Now, we had mentioned, and I think I had said this in that flow chart a couple of slides back, that one way to get information in short-term memory into long-term memory is to rehearse that information. So you may repeat it over and over again. So rehearsal is the repeating of information that has entered short-term memory. Back before we had cell phones, if you were trying to remember a phone number and you didn't have anywhere to write it down, you would repeat the number over and over and over again in your head until you got to the phone in order to make the phone call, or to a piece of paper where you could write it down. Now you don't really have to worry about that because we have cell phones that we have with us all the time. But rehearsal is a way to get information from short-term memory into long-term memory. It maintains that information in short-term memory when it is repeated. If you remember from that slide, a couple of slides back, it was called repetitive rehearsal. So you're repeating the information over and over again. Repetitive rehearsal allows that information in short-term memory to go into long-term memory. So in rehearsing that information, instead of just, maybe using repetitive rehearsal where you're repeating it over and over again, you may use 2 other types of rehearsal. One of those is elaborative rehearsal. And this occurs when information is considered and organized into some sort of fashion. So as you're trying to remember a list of items, perhaps you come up with a song for those lists. Maybe you come up with a story using the words in that list of items. That is elaborative rehearsal. You're elaborating as a way to remember that information. The second type of rehearsal is what we call mnemonics. And mnemonics are strategies for organizing information in a way that it makes it more likely to be remembered. So you may be able to remember the colors of the rainbow by Roy G. Biv, right? Roy G. Biv is a mnemonic. Red, orange, yellow, blue, no, red, orange, yellow, green, blue, indigo, violet, right? Maybe you need to remember the notes on a scale, and we do every good boy does fine, right? And you take the first letter of each word, and that gives you the notes on the musical scale. So we use mnemonics also as a way to remember information. So through rehearsal, we are trying to get information from short-term memory into long-term memory. You can use repetitive rehearsal, which is where you're just repeating the information over and over again. You could use elaborative rehearsal, or you could use mnemonics. Now, we had mentioned that information goes from sensory memory to short-term memory to long-term memory. We also have this other area of memory, which is called working memory. Working memory is a part of short-term memory, so to speak. So once you go from sensory memory to short-term memory to long-term memory, then when you are trying to retrieve that information, you go into long-term memory and you bring it back to the present and you work on the information that you're trying to work on, right? So you are studying for an exam, you study and study and study, that information goes into long-term memory. Then when it comes time to take the exam, you go into long-term memory and you bring the information back into working memory. You bring that information back to the present. Once you're done taking the test, that information goes back into long-term memory again. So working memory is a memory system that holds information temporarily while actively manipulating and rehearsing that information. Working memory has what is called the central executive processor. I like to think of the central executive processor as kind of like the mothership, right? It pulls information out of long-term memory and it determines where that information should go. So working memory has three subsystems. It has a visual store, it has a verbal store, and it also has what is called the episodic buffer. The episodic buffer contains information and represents events and occurrences. Whenever you think about the word episodic, think about the word episode. So it's like an episode from your life. You're going to remember about an event or an occurrence. This is figure 4, and you can find this figure at the top of page 208 in your textbook, but this can kind of show you how working memory occurs. Remember, your central executive, I said it coordinates in material. It's kind of like the mothership. It's going to pull information out of long-term memory, and it's going to determine where that information goes. Is it going to deal with visual and spatial material? Is it going to be a verbal store like speech and words and numbers? Or is it going to be like an episode from your life and go to that episodic buffer? So that is how working memory works. We think of it as like a part of short-term memory because you're bringing it back to the present for a very short period of time, and then it's going to go back into long-term memory again. Talking a little bit more about working memory. Working memory allows us to keep information in an active state so that we can do something with it. So as we pull information out of long-term memory and bring it back to the present, so if we pull information about the exam that we're going to take, we pull that information for the exam out of long-term memory and bring it back to the present so that we can take our exam. As it processes the information, it uses a significant amount of cognitive resources, and the number of chunks that can be held and processed is limited. So the cognitive effort that is involved in working memory can make us less aware of our surroundings. And finally, the stress that you may have at any given point in your life can reduce the capacity of working memory. You may have experienced this when you were taking an exam. Maybe you got in a fight with your roommate the night before, or maybe you got in a fight with your partner, or maybe your car broke down on the way to school to take the exam. Whatever it is, all of those things are very stressful things. And so you have that stress in your mind, and that's going to affect how much information you can bring out of long-term memory and put it back into working memory. Okay, so let's talk about long-term memory. So we went from sensory memory to short-term memory into long-term memory. Long-term memory stores information indefinitely. It says it's a relatively permanent basis. It is permanent. Once information is in long-term memory, it is there to stay. It may be difficult to remember that information at certain points in time, but the information is not lost. Even for people who have a head injury and they forget certain points, certain types of information, over time, that information may come back to them. So that shows us that once information is in long-term memory, it is there to stay. It also has an almost unlimited capacity. We said short-term memory could hold about 7 bits of information plus or minus 2. There is no limit on how much information you can store in long-term memory. So researchers have come up with various types of evidence that we have for long-term memory. People with certain kinds of brain damage may have poor memory performance, but that could come back to them at a later point in time. The results of laboratory memory studies. There has been a plethora of information or a plethora of studies that have been conducted on memory. And a lot of that research has been done in a very controlled laboratory type of setting. We also know that your ability to recall information in a list depends on where in the list that information occurs. So let's say that you're trying to remember items in a list for a vocabulary test. This is what I used to do all the time when I was in high school and we had vocabulary tests. I would say the first word and the definition, the first word and the definition, and then I'd move on to the second word and the definition. And then I would do first word definition, second word definition. And then I do third word definition. And then I do first word definition, second word definition, third word definition. So on and so forth until I had all of those words in the list memorized and they were in long-term memory. Now, research has shown us that when you're trying to remember items in a list, there are certain types of items that you remember the best. One is called the primacy effect, and this is where you are better able to remember the items at the beginning of the list than the items at the middle or the end of the list. And I think this is because of rehearsal. You rehearse that information at the beginning of the list so often. The second way that we can remember information in a list, what we are good at, is what is called the recency effect. And this is where we are better able to remember items at the end of the list. And the reason for this is because it is the most recent information. Perhaps it is just out of short-term memory into long-term memory. So the primacy and the recency effect show us that information at the beginning and the end of the list is better able to be remembered than the information in the center of the list. We have various modules that we use for long-term memory. And so I want to go through each of these. So as what we had was short-term memory, long-term memory appears to have several different components. That is that we have declarative memory, we have semantic memory, and we have episodic memory. Okay? So let's break each of these down. Declarative memory refers to factual types of information. So think about encyclopedia types of information. I don't think people probably use encyclopedias anymore. Maybe it should be Wikipedia types of information. Declarative memory is also sometimes called explicit memory. Semantic memory is our memory for general knowledge. It could be procedural types of knowledge. We also have episodic memory. And if you remember what I said previously, episodic memory is like an episode from your life. So episodic memory is for events that occur in a particular time, place, or context. So we have these three memory modules for long-term memory: declarative memory, semantic memory, and episodic memory. Now, the opposite of declarative memory is what we call procedural memory. And this refers to a memory for skills and habits. Just like declarative memory was sometimes called explicit memory, procedural memory is sometimes referred to as non-declarative memory or implicit memory. So let's go back to looking at a type of flow chart for these. I like flow charts because I think they're really helpful in helping us understand information. This flow chart is taken from the top of page 210 in your textbook. And you can see that here we have long-term memory. We have two different types of long-term memory. We have declarative memory and we have procedural memory. Procedural memory are skills and habits. So, for example, riding a bicycle. Declarative memory, we said, was factual or encyclopedia types of information. So an example would be that George Washington was the first president of the United States. Now, there are two types of declarative memory: semantic memory and episodic memory. Semantic memory is general types of information. So perhaps one of those is that George Washington wore a wig. Episodic memory is like an episode from your life. So perhaps you remember when you went and visited George Washington's home at Mount Vernon. So I think this flow chart is really helpful if you're studying for, a test in class and you're trying to remember the different types of long-term memory. It kind of breaks it down for you in understanding those. The next thing I want to talk about are semantic networks. Whenever we think about semantics, usually is like semantics are words, right, that you're thinking about, that word semantic itself. When we're talking about a semantic network, it is a mental representation of various clusters of interconnected information. So each bit of a cluster is connected to bits of other clusters. This will make more sense in the next slide whenever I show you what we mean by a semantic network. When we talk about semantic networks, activating one memory triggers the activation of related memories. And this is a process known as spreading activation. So this is figure 6 at the top of page 211, and it shows you what we mean by a semantic network. Below it, it says semantic Semantic networks in memory consist of relationships between pieces of information, such as those relating to the concept of a fire engine, right? So a fire engine is red. So off of red, we have various other colors. Off of red, we may also have a rose. Off of red, we may have an apple or a cherry. Well, those are fruits. So then we also have a pear. With red, we may also think about sunsets and sunrises. Those are things that occur in the sky, and then we have clouds, right? With fire engine, this is a vehicle, while a bus and a truck and an ambulance is also a vehicle. Vehicles, ride down the street. So you can see how this is a semantic network. We have one word or one concept, fire engine. And this will lead to all these other different clusters of interconnected bits of information. The last thing that I want to talk about in this module is that if you remember, we went back and we had those 3 questions for the module. And the third question, if you remember, was what are the biological bases of memory? So that's what I want to talk about in these last few slides in this module. I want to talk about the neuroscience of memory. What occurs in your brain for a memory to be stored? The first definition or the first concept is what is called an engram. An engram is a physical memory trace in the brain that corresponds to a specific memory. Your memories occur in your brain in the hippocampus. The hippocampus is a part of the brain's limbic system, so it plays a central role in the consolidation of those memories. Now, we said that the hippocampus is a part of the brain's limbic system. Another part of the limbic system is the amygdala. So the amygdala, if you remember back to chapter 3, we said that was the main emotional center of your brain. So the amygdala is involved with memories involving emotions. This slide shows you where the hippocampus and the amygdala are located in your brain. And they both play an important role in the consolidation of memories. The last slide in this module, we're going to discuss this question: how is the transformation of information into memory reflected at the level of neurons? So we're taking some very broad concepts such as memory and we're taking it to a very micro level. And we're going to talk about the neurons and how those are involved in establishing memories. The first thing to discuss is long-term potentiation. This is when certain neural pathways become easily excited while a new response is being learned. Consolidation is when the memories become fixed and stable in long-term memory. So if you remember, you went from sensory memory to short-term memory to long-term memory. You want to take that information in short-term memory and you want to consolidate it into long-term memory. New research out there in the experimental field of neuroscience shows that a brain implant works like a pacemaker in helping to improve memory. We have what's called a transcranial alternating current stimulation, or abbreviated as TACS. This stimulates the brain and in turn has improved memory in experimental settings. We haven't done this yet in the real world, so to speak, but so far in experimental settings, this has been shown to improve memory. And this is important for cases where someone has a brain injury and you're trying to help them remember information.